Hey guys, Mike here. In this video, we're going to be going over recursion. Now I know I said we'd be going over standard library functions. That we're going to switch the order of those videos. We're going to do this one first, and then we're going to tackle that. So we're going to go over recursion right now, and I have my code written out right here. We're just going to go through it. So in the last video, we were introduced to pattern matching. We have two different cases. We have an empty brackets, meaning the list is empty. And we have a head and a tail, meaning that we are dealing with one element and then the rest of the list. So in this video, we're going to tackle doing the length of list function. So we want to get the length of a list. In this case, and it does right here, as I should have cleared this. In this case, we take our list and we want to see the length, how many elements are in there. So to do that, let's think of an intuitive way to go about that problem, right? Like if I have 1, 2, 3, what do? Well, I start at the front, and I say, okay, I see one element 1, let me count that. I see the second element, let me count that. I see the third element, let me count that. 1, 2, 3, done. The list is 3, length 3, or again, length means the number of elements in the list. So let's dive even deeper to that. So say I'm a program, I see a list. Let's think of it in terms of the head-tail kind of thing. I see 1. Well, that's kind of like our, so in this case, H is 1, and then T would be 2 and 3. I see 1. Okay, I want to count 1. I'll put a 1 there, 1 element counted. I then want to move on to the rest of the list, T. All right, now you're dealing with the list 2, 3. 1's already counted. We accounted for that. We go to 2. Well, that's an element. I'll count that, so I'll say another one. So we have 1 plus 1 is 2, so we have our counts at 2. We'll go to the rest of the list, 3. Okay, 3, I see another element, plus 1, so we have 3, our count is 3, and then go, and then the tail would be 0, so we see 0, and what do? Well, we're done. We see an empty list, no reason to count, plus 0, so our total length, or count of elements, is 1 plus 1 plus 1, which is 3, and that's our length of the list, and that's exactly what we're implementing here. So how do we accomplish this? And that's through recursion, right? Recursion is when we want to do the same operation again and again, but we want to use different like input parameters. So like at first we want to do the expression 1, 2, 3. Then we want to count how many elements are in 2, 3. Then we want to count how many elements are in 3. Then we want to count how many elements are in the empty list. So we just work our way down from 1, 2, 3. And we just count and keep on decrementing our list, or cutting it shorter. Recursion does that. It does the same operation with different inputs, and the beauty of recursion is that it must, so if we have a function here, you'll notice that we call the same function, right, within the function. So the recursion builds up our answer. So it'll call, in a function, it'll call itself, and that's recursion. So what we're going to do is we're going to add this rec keyword for recursion, and we're going to go down and we're going to calculate our length of the list. So we have our function, it takes in an integer list, it outputs an integer, and we're going to say begin match L with, and we talked about begin end, it's good for having a good code block, and when our code gets very complicated, begin end helps us decipher good sections of code. So again, let's talk about that. If we encounter an empty case, there's nothing there, we're just going to output 0. But if we have a head and a tail, we want to add 1, and then we want to do a recursive function. Now, why are we doing this? We're adding 1 because we see a head element, right? We see the head element, that's going to be 1 in the first run through. And then we want to call the function again on T, which is the remainder of the list. So let's go through that. So we're going to start off with 1, 2, 3. Begin match L with, well, it's not empty, and we have a head and a tail. In this case, the head's going to be 1, and we're going to have 2 and 3 as like the tail. So we're gonna add 1, like our counter is going to be 1, so count, like this is just like me typing to keep track, so our count's 1, and our tail is going to be 2, 3. So what do? We call the same function again on 2, 3. So our input's going to be 2, 3. Our head tail representation is going to be 2 cons 3. Our count, well, we count 2, so now it's 2, and then our tail is going to be 3. Same thing, we're passing in 3. It's going to be 3 cons empty list, count 3, and T goes null. And then when we get here, or the tail is an empty list, not null. I don't know what I'm saying. When we get to the empty list right here, we're going to output 0. So we have 1, so 1 plus 1 plus 1 plus 0 is our total output. Like, it chains it together. So what this is saying we're going to do 1 plus the output of this guy, and then this guy will say, well, 1 plus the output of that, so it recursively builds up an answer. So we can even, and to prove that this is something we could do, we can have this, and that'll output like a length of 7, right? It'll go through each element, and it'll get an answer. Now, one thing to keep in mind is that recursion has to break down the problem. We can't have something that says this, right? Length of 1 plus length of list L, really, because then our list remains 1, 2, 3, 4, 6, 3, 2 the rest of our lives. It'll never get anything done. It'll never work for it. And if we do this, our program's just not going to finish, right? It's just, I don't know. Yeah, I think this means that, yeah, it'll just start barking at us, honestly. Yeah, I don't know. It's going to give you some weird error because, again, you're not working down the problem. You just keep on calling the same function, and it's going to go nowhere. The computer's going to run forever, and it's not going to like that. So that's how we do the length of a list. Now we'll do the sum of a list, and I think we'll call it video. And the next video we'll jump, maybe do some more recursive examples on lists, and maybe in the video after that, then we'll jump into standard. Actually, I'm not going to make any promises because I'll probably change it. But let's do sum of list. I have no idea what the sum's going to be, but after we calculate it, then. Again, it's we'll figure it out. Again, it's going to take an integer list. It's going to output an integer. So what do we want to do? Well, we want to say, all right, begin match L with. Well, if we get an empty list, obviously there's nothing in there, so we could just add 0. We obviously want to have a recursive part, so our tail is going to, want to get called. So instead of adding 1, we could just add the value of our head, right? So head represents an integer, right? So in their first call, it's going to be 1 cons the rest of the list. Well, we want to add that 1. So it's very straightforward simplification. And it'll be 21, and indeed 6, 10, 16, 19, 21. So it's going to go through it and add those values recursively. So that's kind of it for recursion. Very quick introduction, and we're going to continue with lists in the next video. See you guys later.